ಮಾಡಿದ್ರ Good morning. Till yesterday's class, we have covered the basics of. Have you seen the recorded classes? No. Okay, fine. We have covered the basic concepts of biology. Later, started with physics. In physics, we have discussed about heat, light, kinetic energy, potential energy, buoyancy, elasticity, viscosity, these concepts. Later, we have discussed about nuclear energy, how nuclear reactor works, the basic functionings, right? Till yesterday, we were discussing about the nuclear fission reaction. Do you know where in Karnataka the nuclear reactor present? Shivanasamudra hydroelectric power plant. See, India is majorly dependent on thermal sources for electricity. Thermal sources means coal, right? Karnataka is majorly dependent on hydel sources for electricity, hydroelectricity, Karnataka majorly. Now we are switching into more renewable resources like solar, nuclear, etc. sources of energy, right? In Karnataka, we have Kaiga nuclear power plant. Have you heard the name? Kaiga. Okay. It's in Karwar Taluk, Uttara Kannada district, Kaiga nuclear power plant. Karnataka's only nuclear power plant. This nuclear power plant, each and every nuclear power plant functional right now works on the principle of nuclear fission reaction. Fission reaction means unstable atomic nuclei continuously it will splitting of atomic nuclei. Upon splitting of atomic nuclei, enormous amount of heat is generated, enormous amount of heat. For the atom to become unstable, generally the radioactive elements, it will not start or initiate a radioactivity suddenly. There should be some addition of neutron or removal of neutron to make it unstable, right? Here what happens, by bombarding or attacking or colliding this atomic nuclei with a neutron, you know what is proton, electron, neutron? Subatomic particles. In each and every atom is made up of positively charged particle, proton, neutral charged particle, neutron. This proton and the neutron combines to form a nucleus of an atom. In the center of the atom, proton and neutron are present. In the outer shells, electron is present. Proton, neutron, electron. This is an atom of any element, hydrogen, iron, gold, etc., any element, right? Here, by bombarding this atomic nuclei, this radioactive element, let's say for example uranium-235, by bombarding it with a neutron, the radioactivity starts. It is a chain reaction, continuous chain reaction. The reaction will continue till the last minute particle of fuel is left, the radioactive element is left. Till then, the reaction will continue. By nuclear fission, fission means splitting of atomic nuclei. Fast moving neutrons are released. neutrons are released, and enormous amount of heat is generated. Enormous amount of heat. Okay. Human successfully controlled this nuclear fission reaction with the special nuclear fission apparatus reactor, right? Where with the help of moderator, controller, etc., he controlled the reaction. Yesterday we have discussed, right? Atom bomb. Atom bomb. This also works on the same principle, nuclear fission reaction. In atom bomb, uncontrolled nuclear fission reaction happens. Uncontrolled nuclear fission means which we cannot control, which we cannot stop. Once the reaction is initiated, complete destruction will happen. We cannot stop in the middle. Uncontrolled chain reaction. In nuclear reactor, it is controlled chain reaction. Whenever required, we can stop the reactor. Our Kaiga nuclear power plant is functioning, it's working. Today, tomorrow, if we need it to be stopped, we can stop it. We can control the nuclear reactor. Okay. Atom bomb discovered by, have you seen the recent web series or movie named Oppenheimer? Oppenheimer. It was in Prime, I think. He discovered the atom bomb. Where in the world till date, there was a nuclear or atom bomb attack happened? Anywhere in the world, did it happen? Nuclear bomb, atom bomb, both are same. Nuclear bomb attack. Yes. During the Second World War time, Second World War, 1945. After the World War only, they gave independence to us, 1947. Right? During the Second World War, 1945, August 6th on Hiroshima, August 9th on Nagasaki, the twin cities of Japan. They attacked these twin cities with two nuclear bombs named on Hiroshima, Little Boy, and Nagasaki, Fat Man. Only two nuclear attacks which happened till date. Later, many countries tested many nuclear weapons. Even we have tested many nuclear weapons. We do have nuclear weapons, but attack happened only on Japan, right? Till date. And nuclear reactor was discovered by nuclear reactor discovered by Enrico Fermi. Enrico Fermi, nuclear reactor discovered by him, Enrico Fermi. Then we have nuclear fusion reaction. Nuclear fusion reaction. Nuclear fusion. See, till this topic we have discussed yesterday. From this we'll continue. Okay. Nuclear fusion reaction. Fusion means what? Combining, right? Fission means splitting. Fusion means combining. Here, heavier isotopes of hydrogen, deuterium, and tritium combines to release enormous amount of heat. They combine to release enormous amount of heat. Along with the heat, for example, helium, hydrogen, etc. might be produced. Again, these molecules will combine. This is also a chain reaction, fusion chain reaction. This kind of chain reaction, the fusion reaction, is majorly seen in Sun and other stars. The primary source of energy to each and every living organism is Sun, right? The energy source of Sun is this fusion reaction. The energy source of Sun is this fusion reaction. It is a chain reaction. It is a continuous reaction. There is no end for it. Then do stars have any lifespan? Yes, actually, stars do have lifespan based on their shapes, right? For example, when compared to other stars, Sun is a medium-sized star, not the smaller, not the bigger. medium-sized star. At any point, sun will not explode. The bigger stars will explode. In few million years only, the bigger stars will explode. Supernova explosion will happen. A star like a sun, the reaction will stop one fine day. The fusion reaction will stop one fine day. If the light, the electricity goes off, it will turn dark, right? No electricity, no power. Like that, one fine day, sun will go dark. But that will take huge amount of time. For example, sun right now is in its youth stage. Sun and solar system, our earth was formed 4.6 billion years ago. 4.6 billion years ago. Billion means 10 power. Million means million 10 power 6, right? 10 lakhs million. Billion 10 power 9. 100 crore. Billion 10 power 9. India will become 5 trillion economy. Trillion means 10 power 12. See 3, 3, 6, 9, 12, 15, 18 likewise. Right? Trillion, 5 trillion means 10 power 12. For example, in human body, adult human body, we have trillions of cells. Just imagine. Lakh crores of cells we have in our body. Okay. Here fusion reaction. Fusion reaction is seen in sun and other stars. Which gas is majorly present in the sun? Hydrogen and helium. Actually, generally, what we think, heliocentric theory we might have heard. Heliocentric theory means sun-centric theory. Earlier, what human thought, Earth is at the center, sun is revolving around us. Later, he got to know, no, sun is at the center, we are revolving around the sun. The Earth-centric theory, geocentric theory. Sun-centric theory, heliocentric theory. Actually, 73% of atmosphere is hydrogen. 73%. 25% is helium. 25% is helium. In an examination, they have given a statement. Which is the most abundant gas in the universe? Most abundant gas in the universe. That is hydrogen. Most abundant gas in the universe. Most abundant gas in our atmosphere? Around us. If carbon dioxide, actually the amount of carbon dioxide, according to the textbooks, it is 0.03%. According to the books. But actually, it has been raised to nearly 0.05%. Just 0.02% rise, causing so much issues. Global warming, polar ice cap being melted, right? So many issues just by increase of some negligible amount of carbon dioxide. Amount of oxygen present around us is 20.9%. Then the major amount of gas around us is nitrogen. Nitrogen. 78% nitrogen is there around us. Nitrogen. Nitrogen, it is a non-reactive gas. Colorless, odorless, non-reactive. Nitrogen. Is there any filter in our nose? Actually, there are small hair-like projections to filter dust. It is there. Mucus to filter dust. It is there. But is there any filter to filter out nitrogen, oxygen? No, right? We inhale the mixture. Complete air we inhale. The air consists of nitrogen, oxygen, and other gases. What will happen? What is the effect on our body by nitrogen? What happens when we inhale nitrogen? No effect. We don't have the ability to inhale, absorb nitrogen. Okay. It will just enter our lungs and it will come out. That's it. We cannot absorb nitrogen. We can only absorb oxygen from our lungs. In our lungs, we have small air sacs, alveoli at the end of each of our bronchioles. right? Around the air sacs, there will be blood vessels that will absorb oxygen and it will give out carbon dioxide. While exhaling, will give out carbon dioxide, right? Here, fusion reaction majorly seen in sun and other stars. Fusion reaction. Then, have you heard the name hydrogen bomb? Hydrogen bomb. Hydrogen bomb? No. Edward Teller. Edward Teller discovered hydrogen bomb. Till date, nobody in the world used this bomb for any kind of attack. Recently, the Delhi attack happened, right? Which explosive they have used? RDX. Basic, normal explosive, chemical. Royal Destructive Explosive. That's it, the common name, right? Here, for example, recently, have you heard about Pulwama attack? Pulwama attack on the army convoy, a truck or jeep rammed into the soldiers' truck and a bus. Nearly 40 soldiers died, right? That attacking truck contained 80 kgs of RDX, 80 kg. 80 kg RDX caused bus explosion. But recently, Indian armed forces recovered 1600 kgs of RDX from various places. Just imagine if they used that much huge RDX, what might be the level of explosion, right? If there is any issue like the Delhi attack, for example, in news, then they will dig deeper. For example, which kind of explosive that is being used, etc. You should be knowing about those things. Here, hydrogen bomb. Nobody till date used a hydrogen bomb. Let's for comparison. The first atom bomb tested, the first atom bomb tested produced heat equivalent to, produced heat equivalent to or destruction equivalent to 20,000 tons of TNT. 20,000 tons of TNT. TNT means TNT, the explosive trinitrotoluene. 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 20,000 ton means how many kg? 1000 kgs, right? 20,000 into 1000 kgs. Just by few grams of, uranium, thorium, etc. Right? 20,000 tons in first atom bomb test. First hydrogen bomb test they have done, right? It produced 10 million tons of TNT. 10 million tons of TNT. The heat energy equivalent to 10 million tons of TNT. Just imagine 20,000 tons, 10 million tons. Million means 10 lakh. 10 into 10 lakh. That much explosion, few small amount of hydrogen bomb will cause. So, when compared to the fission reaction and the fusion reaction, which reaction will produce more energy? Obviously, fusion reaction, enormous amount of energy it produces. So, human thought, see, for any new technology, for any new aspiration, there will be risk involved, right? Nuclear energy, the risk factor is radiation. harmful radiation coming out during the nuclear reaction, right? Here, they have planned to build a nuclear fusion reactor. Nuclear fusion reactor. Fusion reactor. Very, very important topic. Futuristic topic. If anything, in news related to fusion reactor, it's very important to know. Okay, fusion reactor. What is fusion reactor? It is also a type of nuclear reactor which works on nuclear fusion reaction. When compared to normal nuclear reactor, it produces enormous amount of energy. For example, the Kaiga nuclear power plant. Let's say the Kaiga nuclear power plant is supplying electricity to that district, that complete district, let's say. Okay. If in Karnataka we install a fusion reactor that might provide electricity to half of the state, one district, half of the state. That much huge amount of electricity will be produced by this fusion reactor. To develop this technology, there is a global collaboration between 30 plus countries, including India. Only 9 countries participated by contributing money. Other countries, goodwill, technology sharing, etc. they have done. India contributed money also for this project. The project is ITER. Anything in news regarding ITER? Very important. International thermonuclear experimental reactor. Why thermonuclear? It will produce enormous amount of heat. It will produce enormous amount of heat. International thermonuclear experimental reactor. The first assembly, means the basic test module assembly, is in France. The major player in this group is European Union. European Union is the major player here. Along with European Union, USA, Russia, China, India, Canada, etc. Many countries participated in this project, ITER. A year back, the assembly was complete. It is in the test phase. Around the world, right now, 160 plus fusion reactors are in the test phase. No nuclear fusion reactor is completely functional. 160 plus nuclear reactors are in the test or development phase. Test or development phase they are in. In India also, in the developmental phase, we have Aditya. Why the name Aditya? Aditya means sun. In sun, nuclear fusion reaction happens, right? Similarly, here also nuclear fusion reaction is happening. That's why Aditya they have named. Then SST1, super charged, super conducting tokamak. This fusion reactor is also called as tokamak reactor. Tokamak reactor. Supercharged, superconducting tokamak. If any of these things in the news, it will be asked. Okay. Important topic to know. Fusion reactor, the future of energy, the future of energy. The world's first fusion reactor, world's first successfully tested fusion reactor was by China. They have firstly tested HL2M tokamak reactor, HL2M the name, in 2020 itself. 2019 December 2020, HL2M tokamak reactor. Later, they have tested yeast. Yeast. Yeast means experimental, advanced, experimental, advanced superconducting tokamak. Experimental advanced superconducting tokamak. Yeast by China. HL2M by China. Those reactors were called as artificial sun by them. Artificial sun doesn't mean it will produce light like the sun. They will also do the similar reaction which is happening in the sun. That's why in sun also fusion reaction is happening. Here also fusion reaction is happening. That's why it is called as artificial sun. It will not produce light. It will not give light. Right? Fusion reactor. Very important thing. Then half-life. Have you heard the term half-life? No. If you have 10 grams of radioactive element right now, 10 gram of uranium, let's say. When the reaction starts, radioactive decomposition, splitting is happening, the amount of uranium will reduce, right? The quantity will be reduced because the fuel is being utilized, splitting is happening, right? The amount of time the radioactive element takes to reduce to its half of the weight, that time is called as half-life. To reduce to half of its weight, the time it is taking. For example, half-life of uranium 235. 235 is the mass number, 92 atomic number. Half-life of uranium 235 is 700 million years. It takes 700 million years. That means for 10 gram of uranium to reduce to 5 gram, it takes 700 million years. The same uranium for 100 gram to reduce to 50 gram, it will also take the same time, 700 million years. The uranium 1 gram to reduce to 0.5 gram, how much time it will take? Same 700 million years. 0.1 gram to reduce to 0.05 gram, then also it will take the same time, 700 million years. This is the speciality. The time will be the standard, same for any weight. Okay, half-life. Half-life of these three elements, let us remember. Half-life of uranium 235, because this is the fuel which we are using in our nuclear reactors. The fuel which we are using in our nuclear reactors, that is uranium 235, uranium 235. Then heavier isotope of uranium, uranium 238. Half-life of uranium 238 is 4.5 billion years. 4.5 billion years. Billion years. 4.5 billion years half-life of uranium 238. Half-life of radium 226. It is approximately 1600 years. Half-life of radium 226. Radium 226. While preparing for UPSC CSE examination, parallelly, try to apply. You have completed your degrees, right? At least basic degrees you have completed. Apply for central, state, banking level Group B examinations. Group B examinations. For example, every year RBI will call a Group B examination every year. till the age of 27 you can apply, I think. There are many examinations where the cutoff age is 27 years. The central government few examinations. For general examinations, the cutoff age will be 30 years. So plan accordingly. If you have any reservation, the age will be increased by 3, 5, 7 years. But generally, let's stick on to the general cutoff age. Because till the age of 30, we need to be settled. We will be having so many responsibilities in our life, right? So that I'm not telling shift your focus to other examination. I'm just telling by attending other examinations, you will be getting an experience of the examination setup, the examination, how does it feel to write an examination with a number of aspirants, the difficulty, which you can only feel in the real examination. Any a number of mock tests you take. Here, if you give mock test, what you will do? You will be off, no tension, easily you will write any amount of mark you will get. You might not worry, right? But there it will affect you. So better try to attend other examination also. No need to go if you get selected. If you're not interested, if you're interested, you can go. Right? At least try to attend. Half life. Then let's move on to the next topic, gravity. Who discovered gravity? Once upon a time, Newton was sitting beside an apple tree. Suddenly, apple fell beside him or on his head, wherever it might be. Then he thought, why the apple fell to the ground? So he thought, okay, there might be some force of attraction towards the earth or towards the ground. Then he discovered the force called gravitational force. Gravity. Newton discovered it. Newton says each and every object in the universe, each and every object in the universe has a force of attraction, to attract other objects towards it. The force of attraction is called as gravitational force. Each and every object in the universe has a force of attraction, that is gravity. Sir, then due to gravitational force of sun, planets are revolving around it, right? Due to the gravitational force of earth, moon is revolving around earth. Due to the gravitational force of Mars, Phobos, Deimos, the moons of Mars are revolving around it. But why nobody is revolving around us? Because we don't have required mass. Mass matters. Sun is huge. That's why more amount of gravitational pull. That's why how many planets are revolving around the sun? 8. Earlier it was 9. Pluto in 2006 considered as a dwarf planet. Right now 8 planets. 4 inner planets, Earth-like planets. 4 outer planets or gaseous planets or Jovian planets we say. Okay. The first planet from the sun. Mercury. Mercury, Venus, Earth, Mars, then the asteroid belt, then we have Jupiter, Saturn, Uranus, Neptune. Right? Does our first planet Mercury have any natural satellite moon? No, zero. What about Venus? No. Mercury and Venus don't have any natural satellite, no moon to them. The first planet to have a natural satellite is our Earth. It is having only one moon. Next planet behind us, Mars, it is having two moons, two natural satellites. After crossing the asteroid belt, the Jupiter is having more number of moons. The number is continuously changing. Right now, today, as of today, Saturn is having more number of moon, 143 plus moons it is having right now. But Jupiter might be having more. The discovered number of moons, it is more in Saturn right now. In Jupiter, 95 plus moons are present as of the data which we know. There might be more. We don't know. Right. Why the outer planets having hundreds of moons, but the inner planet Mercury, Venus, no moon, Earth only one moon? Because mass matters. Mass matters. For comparison, just imagine Earth, Mars, Mercury, Venus, the four inner planets are there, right? And the four outer planets, Jupiter, Saturn, Uranus, Neptune, four planets. The outer four planets mass is 99% of the total mass of the eight planets. For example, eight planets, the total weight is, let's say, 100 kgs. Let's say 100 kg. The weight of eight planets, 99 kg will be the outer four planets. 99 kg outer four planets, only 1 kg, all these four planets. That is small, the inner four planets. Okay. That too, Mercury is very near to Sun, Venus near to Sun, and this is also small. That's why no moons. The gravitational pull is not enough to have a natural satellite. Earth, little bit bigger in size. Gravitational pull is better when compared to those two planets. That's why only one moon. Only one moon. Newton's law of universal gravitation. Newton's law of universal gravitation. He says, see, object of mass m1, object of mass m2 at a distance of r. At a distance r. Listen. Gravitation or Newton's gravitation, the definition says, each and every object in the universe have the ability or have the force to attract other object towards it. The force of attraction is called as gravitational force. That's it. Now, M1 will be attracting M2, M2 will be attracting M1, right? Both will be having gravitational pull. This force F1, this force F2. Okay. Newton's law of universal gravitation, the equation says, see, before that, the gravitational force that is equals to F1, F2, gravitational force. The gravitational force, will it be directly proportional to the product of the mass or inversely proportional to the product of mass? Directly proportional means if the mass is more, gravitational force more. Inversely proportional means if mass is less, gravitational force more. What is the case? Yes. If the mass is more, gravitational pull will be more, directly proportional to M1, M2. Then the gravitational pull, what is its relationship with the distance? R, directly or inversely proportional? See, let's say, do you know about International Space Station? International Space Station. Have you recently heard the news about Shubhanshu Shukla, our Indian astronaut going into space? Right, Shubhanshu Shukla. Then have you recently heard the news about Sunita Williams? Sunita Williams. She was stuck in International Space Station for many days. Later, successfully, she was evacuated or rescued from there. Right? You know, right? International Space Station is a place in the space, where humans can go and make some observation, research, etc. It is like a flying room. International Space Station. International Space Station is just 400 to 410 kilometers from the surface of the Earth, or mean sea level. How many kilometers above? Around 400 kilometers above. Okay. And the communication satellites, you will be getting hundreds of channels from your DTH service provider, Tata Sky, Airtel, Geofiber, etc. Right? You will be having an antenna above your house. The antenna getting the signal from the satellite. The satellite will be 35,786 kilometer away. How much? 35,786 kilometer away. There is a reason. We'll discuss when we discuss about space technology. Okay. If the object is near, the gravitational pull will be more. If the object is away, the gravitational pull will be less. That's it. So, distance and force will be inversely proportional. If the distance is more, gravitational force is less. If the distance is less, gravitational force will be more. Force inversely proportional to square of the distance. Square of the distance. When we equate these two, we will get what? Hmm? Yes. Force is equals to m1 m2 product of the masses divided by r square. But we need a constant to equate, right? We need a constant. There is proportionality. To equate, we need to have a constant. The constant is called as capital letter G. Gravitational constant. Gravitational constant. Gravitational constant value is values. This is the problem. See, what we think a small letter G, capital letter G, both are one and the same. No, small letter G is acceleration due to gravity. Acceleration due to gravity means if I drop this water bottle, it will move down with some acceleration, right? Acceleration means rate of change of velocity. Rate of change of velocity. The rate of change of velocity is happening because there is some pull, gravitational pull. Due to the gravitational pull, acceleration is there on this object, the falling object, right? Acceleration due to gravity. Acceleration due to gravity value is 9.81 meter per second square. This is acceleration due to gravity. Capital letter G is gravitational constant. Gravitational constant value is 6.67 into 10 power minus 11 Newton meter square per kg square. 6.67 into 10 power minus 11 Newton meter square per kg square. Gravitational constant. The gravitational constant value was discovered by Henry Cavendish. Henry Cavendish. Discovered by Henry Cavendish. In the earlier class, we have discussed about SI units, measuring instruments. Do you know SI units? International System of Units, standards, right? SI unit of distance. Distance is measured in what? What unit? Take a guess. Distance. How much distance you are sitting from me? Some meters, right? Or some centimeters we can also use. Or some kilometers, 0.003 kilometer, we can say, right? The SI unit of distance is meter. SI unit of distance is meter. See, there are 7 fundamental units of measurement. Fundamental units of measurement. Fundamental means which cannot be derived from other physical quantities, which are direct. And we have derived units of measurement. Derived means, for example, area is equals to length into breadth of a rectangle, right? Then circumference of the circle, 2 pi r. right? It is dependent on some physical quantity. Force is equals to mass into acceleration. Speed is equals to distance traveled by time taken. Acceleration is equals to velocity by time. These are derived units. They are dependent on some other physical quantities. There are seven quantities, only seven quantities which are fundamental. The fundamental units of measurement are: one is distance, then temperature, then time, then electric current, luminous intensity, then amount of a substance, then very important one, mass. Take a guess. What is the SI unit of distance? Very good, meter. SI unit of temperature. In India, we use degree Celsius, but SI unit of temperature is Kelvin. SI unit is Kelvin. SI unit of time, seconds. SI unit of electric current. Electric current is measured in ampere. Luminous intensity, the intensity of light coming from the luminous object, for example, sun, bulb, torch, etc. Luminous intensity. Earlier, the incandescent bulb, the filament type bulb, which we were using in the earlier days, right? The incandescent bulb. Later, CFL came. Later, LED bulb came. What you were asking with the shopkeeper to buy this incandescent bulb? Candle, you will be asking, right? 0 candle, 60 candle. That is actually candela. The SI unit which came to our general usage and became candle. It is candela. Luminous intensity SI unit is candela. Then amount of a substance SI unit is mole. SI unit of mass is very good, kg, kilogram. Do you know the difference between mass and weight? Same. These are the seven fundamental units of measurement, which basic thing which we need to know, right? They will not directly ask these questions, but this is the basic thing which we must be know. Okay. See, weight is equals to, it is a derived unit, right? Weight is equals to mass into acceleration due to gravity. Mass into acceleration due to gravity. If a small child asks you to come sit on his lap, what you will do? Small child sitting on the chair, he asks you to come sit on his lap. You will not put weight, you will just simply sit, right? If your friend asks, you will try to put more weight, right? Weight means mass into acceleration due to gravity. Weight is equals to mass into acceleration due to gravity. Mass is the measure of body's inertia. That means this water bottle, there are some fixed number of molecules present in it. For example, let's say 4 molecules are present in it, only 4 molecules. If I take this water bottle above the moon, only 4 molecules will be there. If I take this water bottle above the Mars, only 4 molecules will be there. That will not change, right? Mass is a constant factor, constant. It will not change anywhere it will not change. Mass will remain constant. In an examination, they have asked when Neil Armstrong, who is Neil Armstrong? The first person to step on the moon, right? When Neil Armstrong stepped on the moon, what happened? Weight remained constant, mass changed, mass remained constant, weight changed. Like this, they have asked in an examination. Mass is constant, mass will not change. When Neil Armstrong stepped on the moon, the weight remained the same. No, mass remained the same, right? Mass will be the constant factor. Weight will change because acceleration due to gravity, this gravitational factor, this will change. If the gravitational force is more, weight will be more. If the gravitational force is less, weight will be less. For example, when compared to the gravitational pull of Earth, when compared to the gravitational pull of Earth, the gravitational pull on Moon is only 1/6 of that of Earth. 1/6 of that of Earth. Okay, let's say if your weight is 60 kgs, if your weight is 60 kgs, what will be your weight on Moon? 16 to 1 by 6. That is 10 kgs. 16 to 1 by 6, right? 60 by 6. 10 kgs. If your weight is 60 kgs on Earth, your weight will be 10 kgs on the Moon. Reduce your weight by 50 kgs in one day just by going to the Moon, right? That is possible. When you come back, it will be the same. If acceleration due to gravity value changes, weight changes, but mass is constant. Mass is constant. Actually, listen, actually, SI unit of weight is Newton. SI unit of weight is Newton. But what do we use in daily life? Kg, gram, kilogram, right? We use kg for weight, but actually the SI unit is Newton. Weight's SI unit is Newton. Mass's SI unit is kg, kilogram. SI unit of mass is kilogram. Mass, kilogram. Acceleration due to gravity value will change. This is the standard value which we have considered. But it might change. It will change on various places on the surface of the earth. We'll discuss. This is a constant value, capital letter G, capital letter G. Law of universal gravitation. What does it say? If mass is more, gravitational pull will be more. If the distance is more, gravitational pull will be less. That's it. That is the basic concept. Okay. Then here, what is the shape of the earth? Geoid. What is the shape of the human being? Humanoid. That's true actually. See, have you heard the name humanoid robot? A robot in the shape of humans are called as humanoid robots. Okay. Likewise, the shape of the earth called geoid. That is nothing but the shape of the earth. Both are one and the same. Right? Earth is geoid. Geoid means in the polar region it is flat. Right? In the polar region it is flat and bulged in the middle. In the equator region it is little bulged. Bulged in the equator region. North pole, south pole, we have. This is our equator. From the center of the earth to the pole, from the center of the earth to the equator, where distance is more, where distance is less. That's true, right? Reason the shape of earth is like that. It is not a perfect sphere, it is a oblate sphere, we can say. Oblate sphere means bulged sphere, right? The shape of the earth. Gravitational pull is dependent on the mass. It is also dependent on the distance, right? If the distance is more, the gravitational pull will be less. If the distance is low, gravitational pull will be. Now tell me A, B, where the gravitational pull will be more? Because the distance is less. right? Because the distance is less, gravitational pull will be more. So in an examination, many examinations, they have asked where on the surface of the earth weight of a person will be maximum. Where on the surface of the earth weight of a person will be maximum. Weight is equals to mass into acceleration due to gravity. Mass will not change. It is a constant value. What might change? The gravitational force. Acceleration due to gravity. Where gravitational force is maximum? Polar region. In both the poles. Acceleration due to gravity value is more here. Acceleration due to gravity value is more here. The reason? Distance from the center of the earth is less. That is the reason. Okay. The weight will not drastically vary. For example, if your weight is 60.3 kg here, it might be 60.1 kg, 4 kg, 5 kg. Likewise, 60.3 here, it should be more or less. 60.5 it might be. That much little variation will be there when compared to equator and polar region, right? Where on the surface weight is more? At the poles. At the poles. Reason? From the distance is less, right? Then imagine you are going deep into the earth. You are going deep into the earth. Towards the center, you are going deep into the earth. You are some 100 kilometers deep. 5 kilometers deep into the earth. 100 is too much. 5 kilometers deep into the earth. Your weight will increase or decrease. See, listen. What we generally think is the distance from this point to this point is less. If the distance is less, weight will increase. That's what we are thinking, right? But the actual reason or actual thing happening here is, see, effective mass of earth below you is this much, right? You are standing deep inside the earth. The amount of earth which you are standing above is only this much, right? That will be the weight of the earth below your feet. Then the mass of the earth, effective mass of the earth is reduced. If effective mass of the earth is reduced, then weight will be massless, means weight will be less, low. This is the confusing point. Imagine, say, this is the size of the earth. This is the size of the moon. Size of the earth is more, that's why gravitational force is more. Size of the moon is less, that's why gravitational force is less. If gravitational force is 6, here it will be 1. Comparison, 1/6. Okay, that is the ratio. Here, if this is the shape of the earth, consider ragi ball flattened on both the sides. That will be the shape of the earth. Or orange flattened on the top and bottom, right? The whole mass of the earth will be considered right now because you are on the surface of the earth, either on the equator or on the pole. In that condition, the weight will be more when you are in the polar region. When you go deep into the ragi ball, when you go deep into the orange, the effective mass of the orange below you will be less, right? The effective mass of earth below you will also be less here. That's why mass of the object is reducing. That's why gravitational pull also will be reducing. So your weight will also be less. This much. Why? Mm. 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 Because yes. Mm. Mm. See, yes. What you are thinking is This is the shape of the earth. For example, let's oblate it even more. If I am here, this is the mass which I am standing on. If I am here, this is the mass you are standing on. You are thinking like this, right? The mass will be little less. That will not happen because there is a complete object in that shape, right? If you go deep into the earth, this is also a oblate sphere. This is also a geoid shaped object, but the size is little reduced. That's it. That's why when you go deep into the earth, the weight reduces, right? The shape itself is oblate sphere or geoid. That is the reason. Small letter g value will vary on the surface of the earth itself. For calculation purpose, for a standard value to know, we have considered how much? 9.81 meter per second square. Acceleration due to gravity. Acceleration due to gravity means the acceleration with which the object is falling down. That's it. The acceleration with which earth is pulling us towards it. That's why we are standing easily on the earth. If the gravitational pull, small letter g value increases rapidly, what happens? We will be stuck to the earth. We cannot even get up, move. If it reduces drastically, we will be floating, right? That is the reason. That is the reason on moon, if a person walks, he will be floating kind of thing. That's why moonwalk, we say, right? For us to answer this topic, the basic concept which we need to know is this thing, right? Mass directly proportional to the gravitational force, distance inversely proportional to the gravitational force. That is the thing. Then there is a famous lift problem, which they are asking from many years in many examinations. The famous lift problem. See, a person is standing in a lift, going downward with some acceleration, going upward with some acceleration. Lift is going down with some acceleration, lift is moving up with some acceleration. In which case, first, second, in which case, weight of the person will increase. Simply hold your mobile phone or any heavy object, try to move it up and down. When you will feel the weight coming down, right? Coming down or going up. You feel the weight. Just feel by holding. If it is light, you cannot feel. If it is heavier, you can feel. When you can feel. When I lift this object, when I keep it down, when I feel the weight, by lifting, right? By lifting, right? Same thing. Here, weight is equals to mass into acceleration due to gravity. To this acceleration due to gravity, this acceleration will be added. Here, weight is equals to mass into acceleration due to gravity. This acceleration will be subtracted. That's it. While going down, the weight will be little reduced. While going up, the weight will be increased because of the acceleration of the lift. Because of the acceleration of the lift. That's it. SI unit of force, Newton. Force's SI unit is Newton. Force means the physical quantity required to change the position of the object from the state of rest or motion. If the object is here, by applying force, I can change its position, right? That is force. By applying force, I can change the position of the object, or speed of the object also I can change. If it is moving in 1 kilometer per hour, by applying force, I can change the speed. That is force. Force. Before going here, let us discuss scalar quantity. Any physical quantity, weight, speed, distance, gravity, anything, any physical quantity which is having both, which is having only magnitude and no direction, that is scalar quantity. Vector quantity means both magnitude and direction are present. Both magnitude and direction. For example, from my home to the institution, I am traveling in different path. Okay. Somewhere I go right, straight, etc. I'm moving. It is taking me around 30 kilometers. Okay. The distance. If I travel by helicopter, if I travel by a drone that has the ability to carry me, if I travel, the path of travel will be like this straight line, right? If I travel like this, the shortest distance between the start point and end point is called as displacement. Displacement. The shortest distance between starting and ending point is called displacement. Displacement. The actual path traveled is called as distance. Actual path traveled. Distance. Actual path traveled. If I come by the road, it is taking 30 kilometers. If I come by drone or helicopter, it might take some 18 kilometers. Right? The straight line. Which physical quantity, distance and displacement, is having both direction and magnitude? Direction means single direction. Which one? Displacement, right? Displacement is having both magnitude and direction. This is vector quantity. Vector quantity. Here distance, it is having magnitude but not a single direction. Sometimes I am traveling north, sometimes I am traveling east, right? Not a single direction I am traveling in. That's why only magnitude is there, no direction. So it is called as scalar quantity. Scalar quantity. Distance, scalar quantity. Displacement, vector quantity. Vector quantity. Okay. Likewise, speed. Speed is equals to distance traveled by time taken. Velocity is equals to displacement by time taken. SI unit of both speed and velocity is meter per second. SI unit is meter per second. Distance traveled by time taken, displacement by time taken. Which is scalar, which is vector now? Distance, scalar quantity. Hence, speed is also scalar quantity. Displacement, vector quantity. Hence, velocity is also vector quantity. Acceleration means rate of change of velocity. Acceleration means velocity by time. Scalar or vector? Velocity is vector quantity. Acceleration is also vector quantity. Vector quantity. See what happens when they start to ask a question about any concept. They will dig deeper and try to make many statements about the topic. During that time, they might ask a question about the basic concept, which we should be knowing, right? These are all the concepts which we all have studied till 10th. We all have studied, but we forgot. That's it. That is the reason we need to recall, remember. Same thing with other subjects also. We need to cover 6 to 12 NCERT. That's must. Okay. See, this object, I am applying force in both the direction. That's why it is in equilibrium. If I just put my finger here and remove the finger, what will happen? It will fall off. Unbalanced force. For an object to stay in equilibrium, balanced forces should be there. The minimum amount of balanced forces required are two. Minimum force required to balance an object is two. Action, reaction, at least two forces are required. Here, centripetal and centrifugal force. In a circular path, object is moving. Circular path, object is moving. If the force of attraction is towards the center, force of attraction is towards the center, then this is called as centripetal force. Centripetal force. Force of attraction towards the center. When an object is moving in the circular path, if the force of attraction is away from the center, then this is called as centrifugal force. Centrifugal force. Can you name any application or any example of centripetal force? Force of attraction towards the center. Yes, very good example. Planets revolving around the sun, right? At the center, sun is there. Towards the sun, all planets are revolving. Centripetal force. Moon revolving around the earth. Artificial satellites revolving around the earth. These are the examples of centripetal force. Example for centrifugal force, away from the center. When a vehicle moving in a circular path or curved path, moving in a curved path, what will happen? It might fall off if it goes faster. A vehicle moving fast while taking a turn, it might fall off, right? That is due to centrifugal force. That is due to centrifugal force. Imagine you are traveling in a car. Imagine you are traveling in a car. When there is a steep left curve, the car turns. Then you will move towards the right, away from the center. That force is called a centrifugal force. Centrifugal force, away from the center. Towards the center, centripetal force. Examples for centrifugal force. Separation of fat from milk. See, generally what we do at our home, we separate butter from curd, not directly from milk. Curd is produced later by churning curd, the fat butter, it is separated, right? While churning the curd, the older method by that big wooden bob and with that rope, right? Circular motion, the fat gets separated and moves away from the center. Centrifugal force, right? Centrifugal force. Here in Nandini milk packets, there are so many different colored packets available, right? Orange, green, etc., etc., where the rate is different because the fat content is different based on the percentage of fat. The lesser priced milk will be having less amount of fat. The more priced thick milk will be having more amount of fat. The fat from the milk is separated by the similar process, churning of milk. Churning of milk. The fat gets separated. The force used here is centrifugal force. In your home's washing machine, have you observed in the washing machine, the holes will be there like this? Front load washing machine, holes will be there. Water and detergent will get mixed up with the cloths. After some rotation, it will start to move at a rapid pace. Then the holes will be opened inside the drum. The holes will be opened by that time. Then the water, the dirt, etc., will move away from the center, right? It will move away from the center. Away from the center means which force? Centrifugal force. Washing machine works on the principle of centrifugal force. Washing machine. Then while taking a turn, if a car overturns, this is also due to centrifugal force. Away from the center it is moving, centrifugal force, right? This planets are revolving around the sun, moon revolving around the earth, etc., are the examples. Centripetal force. See, in case prelims examination, they have asked a question. A biker is moving in a curved path. A biker is moving in a curve. Okay. This curve, imaginary circle, right? Imaginary circle. In a curved path, he is moving. He is moving at higher speed. He is moving at higher speed. To avoid going out or falling off from the curve, he bends the bike towards the center, right? If he is moving left, he bends the bike towards his left. He is moving from that direction, he will be moving towards his right, right? Towards the center, he is moving or bending his bike. Why he is bending his bike towards the center? To gain the necessary dash force, they have asked. To gain necessary dash force, a biker moving in a curved path is bending his bike towards the center, they have asked. In the curved path, the main force acting on the biker is centrifugal force. Right? The main force acting is centrifugal force. To balance that force, he is bending towards the center. When you see 400-meter running race, even the runners will be moving little slant bend right towards the center to gain the necessary what? Centripetal force. To gain the necessary centripetal force, he is bending the bike. The amount of inclination should be balanced, right? If we bend more, he will fall off. If we bend less, he will go out, right? This is called as balancing. Examination they have asked, in a circular curved path, a person is moving in his bike. To avoid falling off, he is bending his bike towards the center to gain necessary dash force, to gain necessary centripetal force. To gain the necessary centripetal force, he is bending his bike towards the center, right? Have you seen ring of death, wall of death kind of a thing in rural fairs? This kind of structure where inside which bike, car, they will, right? If they go slow, they will fall off towards the center. The amount of force acting will be more, will be centripetal. To maintain that centripetal force, they are going very fast straight. If they move very fast, they will come up and one fine point they might come out, right? That is centrifugal force. The balance is happening, that's why they are moving in that circular path. Here also centripetal, centrifugal forces are acting. In an examination they have asked, a car is moving in the circular path. Car is moving in the circular path. Let's say a car moving here, and here is another car. Okay. This car is moving in this direction, this car is moving in this direction. If both the cars travel at a very high speed and both the cars fall off the curb, they both fall off, which wheels will leave the ground first? They have asked in an examination. Which wheels will leave the ground first? They have asked. Sir, in car we have four wheels, two in front wheels, two back wheels. But here they have given the options like inner wheels, outer wheels, all the four wheels. Like this, they have given the option. Inner wheel means this is the imaginary circle, right? This is inside the circle. This is outside the circle. Force acting away from the center is centrifugal. Towards the center is centripetal. Now, due to which force they are falling off? Centrifugal force. Due to centrifugal force, they are falling off. Which wheels will leave the ground first? Whether these inner wheels, whether these inner wheels are the outer wheels. Which wheels? Just imagine you are driving a car. If you take sudden left turn, to which side the car will fall? You are traveling in a car. You take sudden right turn. The car will fall towards the right. Which wheel will lift first? Yes, that means the inner side, right? The inner side. If you are going in the car, if you suddenly turn right, the car will fall to its left. The right side wheels will be lifted first. Right to you will lift it first. That means inner wheels will be inner wheels. Inner wheels will be lifted first. Right? True, right? Like this, they make you to think. Applied science questions, that's it. Application of centripetal fugal concept to real life example. Electricity. Is this the form of energy? Yes, right. 2 minutes. ಎಲ್ಲಿ ಬಿಡಿ ಒಂದು ದೊಡ್ಡ ಬಾಟಲ್ ಇಟ್ರೆ ಬೆಟರ್. ಹಾ, it's a form of energy, electricity. Electric charge, electric current will be there in this socket. If I put my finger inside, I'll get shocked. Electric charge will be there in the UPS battery. Will be there in the cell present in your TV remote. If I touch both the terminals, nothing will happen. True, right? If I touch both the terminals of the battery, what will happen? Nothing will happen. Even the bigger battery present at your home, UPS battery, that will also not give you any sort of shock. Right? Why? Because those two are different types of electric current. One is AC current, alternating current. One is DC current, direct current. AC current will only give you shock. DC current will not give shock. Simple. In which form electricity can be stored, AC or DC? See, earlier, during our childhood days, during the time of summer, there will be very higher number of load shedding, right? Load shedding. Current used to go off regularly, right? During the time of summer. If in case you went to your native, any village, there will be no current. In the morning 2 hours, evening 2 hours, they used to give, right? The problem. Why is that? Thank you. Why was the problem there? Because Karnataka was majorly dependent on hydel sources for electricity. Hydel sources. During the time of rainy season, the dams were full. Then we used water stored in the dam to produce electricity regularly. During the time of summer, no water, no electricity. That's why less amount of electricity was produced. We managed in that. We managed. But right now, no load shedding, nothing, even in the summer, because we are continuously switching to other sources of energy like coal, nuclear, then solar, etc. That's why we are managing. We don't have any issue right now. If, for example, the major source of electricity to Karnataka, Shivasamudra hydel power plant, if all the power terminals are stationed or which are producing electricity there shuts off for 4 days, what will happen? We will not get electricity for 4 days. We might get electricity from other sources, but that source electricity will be gone. Reason, AC current, alternating current. You might have seen while traveling from Dharmasthala or Mangalore to Bangalore, you might have seen big high tension wires coming from the Western Ghats towards the cities, right? Reason, the electricity which is being produced there right now is being transmitted to our home at the same time. It is live transfer of electricity happening. Electricity cannot be stored in AC form. It can only be stored in the form of DC current. But we cannot practically offer huge quantity of batteries to store electricity to feed a city, right? For small plants like a home, small industry, we can store electricity with the help of UPS. For big cities, that is not possible. That's why rarely current goes off due to those fluctuations, and many other reasons are there, right? Alternating current, AC current, can it be stored in its true form? No, it cannot be stored in its true form in AC form. DC current, direct current, it can be stored. It can be stored. Alternating current, AC current, direct current, DC current, alternating current, AC current. Karnataka government is giving 200 units of electricity free based on the previous year's average, right? 1 unit means how much? 1 unit of electricity means 1 kilowatt hour. 1 kilowatt hour, 1 unit means 1 kilowatt hour means 3.6 megajoule. 3.6 into mega means how much? 10 power 6 joule. 3.6 into 10 power 6 joule, megajoule. See, when we are measuring any values, etc., we will be using mega, giga, like this. When we are counting any numbers or objects, we will be using million, billion, right? 3.6 megajoule, 1 unit, 1 kilowatt hour. 1 kilowatt hour means electric bulb was discovered by bulb. In each and every GK examination which we have faced in school days, they used to ask this question many a times, right? Thomas Alva Edison. Thomas Alva Edison. After how many failed attempts, he developed the electric bulb, right? It was incandescent bulb, filament type bulb, filament type light bulb. Which filament was there? Tungsten. Tungsten filament was used. Why tungsten filament? Because the melting point of tungsten filament was more. Melting point was high. 3422 degree Celsius melting point tungsten. And the air filled inside that bulb is not the normal air. It is argon, inert gas argon, or even nitrogen can be filled, argon or nitrogen, to avoid any corrosion of that metal. Generally, metals corrode, oxidation happen, right? To avoid that, argon or nitrogen is in that. Electric cell. Which form of energy is converted into which form of energy from the electric cell? If you are connecting it to a bulb, cell present in your TV remote, battery, which form of energy is converted to which form of energy? Chemical energy, right? Chemicals are present inside that battery. Chemical energy converted into electrical energy. Chemical to electrical energy. Do you know dynamo? Dynamo. Have you seen the earlier days cycle? Bicycle. In that bicycle, there was a special apparatus in the rear wheel which we used to engage and disengage. If we pedal faster, the light glows brighter. If we pedal slower, the light glows less brighter. The instrument engage, disengage to the rim of the cycle. That is dynamo. Dynamo converts mechanical energy to electrical energy. Mechanical to electrical energy. Like this conversions is also important. Okay. Here, electric cell was discovered by Alessandro Volta. Alessandro Volta. Volta discovered the electric cell. Alessandro Volta. Household electric current voltage is how much voltage electric current which we are getting to our home? 220 volt. How much? 220 volt. AC current or DC current? AC current, alternating current. We are getting to our home. If the current goes off, we need backup, right? Power backup. The power backup is UPS. Uninterruptible power supply. Uninterruptible power supply. UPS we have. The UPS battery, the electric current is stored in the form of which? DC current. AC current converted to DC current with the help of which instrument? Alternating current is converted to direct current by the help of an instrument called as rectifier. AC current converted to DC current with the help of a rectifier. Then DC current is converted into AC current, alternating current, same to 20 volt with the help of an instrument called. Have you seen the movie Three Idiots? In Three Idiots movie, all those three guys went to principal's elder daughter's wedding. When they were caught by the principal, what they tell? Sir, we are here to make some experiment regarding our new invention called virus inverter. Have you heard? Virus Sasrabuddhi inverter. Later, during that first daughter's delivery, current goes off due to heavy rain in Mumbai. Then they will collect all the batteries and convert that DC current into AC current with the help of that inverter. Inverter. Inverter means which converts DC current to AC current. That's it. Inverter. Inverter converts direct current into alternating current. Direct current into alternating current, AC current. Inverter. DC to AC converted by inverter. AC to DC converted by a rectifier. That's it. Electric current is measured with the help of an instrument called ammeter. With the help of ammeter, electric current is measured. Electric current. Electric current means through a current carrying material wire. So this is the wire. Charges are flowing. Electrons are flowing. Right? Electrons are flowing. The rate of flow of charge is called as electric current. Electric current means rate of flow of charge. That's it. Electric current. A rate of flow of charge, electric current. Then electric potential difference, generally we say voltage. Electric potential difference. Electric potential difference is measured by voltmeter. The SI unit is volt. That means if I charge my mobile phone with a power bank, my mobile phone will be charged because the voltage in the power bank will be more compared to the battery present in my mobile phone. Right. That's it. That is potential difference. The voltage difference. The difference in electric potential. Difference in the electric potential. Here, ammeter is generally connected in series to the circuit. Voltmeter is generally connected parallel to the circuit. Why parallel? To find out the difference in potential between these 2 points. But electric current, it is finding the flow of charge through that wire, right? That's why it is connected in series. Voltmeter in parallel connection. That's it. In an examination, they have asked which kind of electrical circuit we are having at our home. Series connection, parallel connection, both none. Series connection means serial set. If I switch on, if I switch on a single switch, each and every light operators will be switched on. If I switch off, everything will switch off. That is series connection. But here at our home, see, before that, straight line indicates wire. In an electrical circuit, straight line indicates wire. A bigger line, small line indicates battery. Battery. Okay. These two indicates AC power supply, alternating current power supply. Okay. This symbol indicates a switch. This lever is open, right? Switch is in the off condition. If it is above this, switch is in the on condition. Switch on off condition. We are getting alternating current to our home, AC current. See, at our home we are having a circuit like this, right? Complete switch off with the help of a master switch, main switch. Then we have separate switches to control each and every electrical operators, TV, light, etc. We have combination of series and parallel circuit. A basic series circuit along with we have parallel connection. If they ask only series or parallel, then we should say we have parallel connection. Parallel connection at our home. Parallel connection we do have. Electrical conductance or conductors. For a material to be a good conductor of electricity, it should be having the ability to carry charges. It should carry electric charge. In the same Three Idiots film, we got to know that salt water is a good conductor of electricity, right? Is pure water is a good conductor of electricity? Is pure water a good conductor of electricity? Yes or no? Pure water means this water. Is this pure water? Rainwater is pure water. The water which we are drinking will be having some minerals in it. Along with H2O, dissolved minerals will be there. Generally, we call it as fresh water, drinking water. Okay, this is not pure water. But by advertisement, what they say, pure it data hai sabse shuddha pani. But that is not pure water. That is fresh water itself. Pure water means only H2O, no dissolved salts, zero dissolved salts. Pure water is distilled water, which we use in battery, etc. That is not suitable for any human usage, drinking, washing, cleaning, etc. That is not suitable, right? That is pure water. Rainwater is soft water. Soft water means the dissolved salts content is less. Underground borewell water might be hard water, depends on the place. Hard water means the amount of dissolved salt is high. Dissolved salts are high means hard water. Dissolved salts are less means soft water, right? But the suitable water for drinking is fresh water. Fresh water. Will this water conduct electricity? Yes, 100%. Shock ಹೊಡೆಯುತ್ತಾನೆ ಮನೆಯಲ್ಲಿರೋ ನೀರು. It will conduct electricity. Pure water, distilled water will not conduct electricity because it does not have any free ions to carry the charge. It will not be having any free ions to carry the charge. It is a bad conductor of electricity. Salt water, more number of ions or salts dissolved which can carry the charge. That's why it is a good conductor of electricity, right? When compared to fresh water, hard water is still a good conductor of better conductor of electricity. Generally, metals are good conductors of electricity, right? Metals are good conductors. Wood, wall, floor, plastic, glass, insulators, bad conductors. Reason, they don't have free electrons. They don't have free electrons, right? Free electrons should be there to carry charge. Only non-metal, which is a good conductor of electricity, that is graphite. Graphite is an allotrope of carbon. Where do you generally see graphite? Have you seen graphite anywhere? Hmm? Hmm. That's okay. But in daily life, have you seen graphite anywhere? We all have used graphite regularly in our school days. Pencil, pencil nib. The pencil nib which we used to write, right? That is graphite. Generally, what we call lead pencil, we say, right? Earlier, during the time of Romans, around the graphite, the covering part was lead. Lead. Lead is poisonous, right? Then they got to know lead is poisonous. This should not be used. Later, they switched to wood, etc. The Apsara Nataraja pencil, we had a plastic wood around it, right? That part they had lead. That's why the name lead pencil. Earlier also they were using graphite. Right now also we are using graphite to write. Graphite is a good conductor of electricity. If you mend both the ends, keep it inside the electrical socket, switch on the light and touch. What will happen? Shock. Good conductor of electricity. Graphite. It is having free electrons to carry charge. Graphite. Electrical resistance. Electrical resistance. Resistance means opposition. Opposition to the flow of charge. Through this wire, electrical charges are flowing by the material, the amount of obstruction which is causing to the flow of electric charge, that is called as electrical resistance. Obstruction to the flow of electric current. Obstruction to the flow of charge, electrical resistance. It is measured in the units called ohms. Electrical resistance is measured in ohms. OHM, electrical resistance. Okay, fine. Take a break. We'll discuss superconductors, etc. later.
ಬ್ಯಾಟ್ರಿ ಡೌನ್ ಆಗಿದೆ ಸರ್.
Okay. Shall we continue? What is your daily routine? Study routine, at least. Have you fixed any routine? Hmm? Not yet. Fixed. The routine is? Tell me the routine. Two subjects. 6 to 9. One out of four, one out of four, one out of four, two sessions, huh? Okay. Hmm. Okay. Hmm. Okay. You have selected the optional subject. Which one? Public administration, right? Still planning to choose. Okay. Good. Okay. First, very important thing. Please concentrate on current affairs. Make a regular notes. First, you need to know what are all the current affair topics which you need to cover. Regularly follow any daily current affair class online available for free, right? In the morning, you make notes by reading Hindu, right? Cross check which are all the topics you have already covered, which you have missed. Later, the missed topics cover in the evening session, right? And there will be many news from PIB, right? Press Information Bureau. Press Information Bureau will give the news. That news will be taken by the newspapers and they will publish. The main source, PIB, right? Visit PIB website. By visiting the website, you will be getting different important topics. From that also you can make notes. Okay. In the morning, make notes by yourself. In the evening, cross check, revise. Current affair really requires at least 20-30% of your preparation time. So give proper time for current affairs. Right. Resistance means obstruction to the flow of electric current, right? Obstruction to the flow of electric current, electrical resistance. A resistance, it is directly proportional to temperature. Generally, upon using your mobile phone for longer duration, it will be heated, right? Why? Electrical equipment, by the flow of charges, the temperature will automatically rise. That is common. If the temperature rises in any electrical apparatus, the efficiency reduces. That is the reason. In your computer there will be a fan, right, to cool down. Then usually the IT companies will be set up in air conditioned rooms. Reason, not to cool you down or give you comfort, to keep the temperature low, right? That is very important. If the temperature increases, the resistance will also increase, directly proportional. If the temperature reduces, resistance will reduce. If resistance reduces, electrical conductivity will increase. Conductivity increase means resistance decreases, right? Superconductor. Superconductor. In a superconductor, conductivity will be infinite. Conductivity infinite conductivity. Then a resistance will be nearly zero. Resistance will be nearly zero. This condition is called as superconductivity. Superconductivity. Normally, the metals like lead, gold, etc., all the metals, when cooled down to very low temperature, they will behave as superconductors. For example, lead at a minus 7.2 Kelvin temperature, lead will behave as a superconductor because temperature resistance directly proportional. If the temperature reduces, resistance will also reduce. That is the case. Hans Christian Ørsted. Hans Christian Ørsted discovered electromagnetism. Electromagnetism. In your school, have you done this experiment? A nail wounded with copper wire connected to a battery. When electricity is flown from positive terminal to negative terminal, the flow of charge will be. Direction of flow of electric current will be from positive terminal to the negative terminal. Okay. If current flows through this wire wounded around a nail, what will happen? It will behave as a magnet. Current carrying wire will produce magnetic field around it. Current carrying wire will produce magnetic field. This concept was discovered by Hans Christian Ørsted. Hans Christian Ørsted discovered electromagnetism. This will attract small iron particles. The magnetic field is less compared to a normal magnet, but it will produce magnetic field. This is called as electromagnetism. There is a right hand thumb rule to explain this electromagnetism, not this Faraday's thumb rule, this right hand thumb rule. This rule says the thumb finger indicates current carrying wire. Thumb finger indicates current carrying wire. The other fingers around it indicates magnetic field lines. Current carrying wire and magnetic field lines. What is the angle between the thumb finger or current carrying wire and the magnetic field lines? Angle perpendicular 90 degree. Angle between electric current carrying wire and magnetic field lines is perpendicular 90 degree. Electromagnetism, right? A magnet will be having north and south poles. Magnets are available in very different shapes, right? Horseshoe magnet, bar magnet, dumbbell shaped magnet, oval shaped magnet, circular shaped magnet, different shapes of magnet. Each and every magnet will have how many poles? 2 poles. If we cut the magnet to 2 equal halves, will the pole be separated? Can we separate 2 poles of a magnet? Can we separate 2 poles of the magnet, north, south? Can we separate? No, not at all possible. What happens if we cut here south, here north, 2 separate magnets, right? Inside the magnet, the particles are arranged in a particular lattice. If you hammer, if you drop, if you hit the magnetic property of the material will reduce. Generally, where we got our magnets to play from during our childhood, behind the speaker, we had this circular shaped magnets, right? If you are two children at home, two piece, four children at home, four piece, right? Magnet. If you have two pieces of magnet, many a times you might have tried. One side it attracts, other side if you try to flip and forcefully attract also, after some time if you loosen the grip, it will flip and attract, right? Because magnet has a special property, that is it attracts what? Opposite poles are attracted, like poles will be repelled, like poles will be repelled, opposite poles will be attracted. And a magnet is having directional property. In the compass we use magnetic needle, right? Compass, compass, magnetic needle. In your school, have they shown by placing bar magnet freely suspended bar magnet. If you tie a bar magnet to a thread and place it freely, it will rest in which direction? North south direction. A bar magnet freely suspended will always turn to north south direction, right? Because inside our earth so many metal etc are there. Our earth will also behave like a magnet. Our earth is also having magnetism. Earth is also having magnetism. That's why towards earth's north pole, towards earth's south pole, the magnet is attracting. That's why it turns north to south when freely suspended. See, this side of the magnet showing north pole, this is showing south pole, right? The magnetic needle present in the compass. This is our earth, north south. Inside you have bar magnet. Which pole of the bar magnet is attracted towards north pole of the earth? Means very good, because opposite poles attract each other, like poles repel, right? That's why south pole of the south pole of the bar magnet is attracted to north pole of the earth. Here also in the compass, one side will be marked some color or dot. It will be showing north direction. This pole is called as north seeking pole. North seeking pole means it is showing a north direction. Which is the pole of this magnet? This is south pole. South pole of the magnet showing a north pole of the earth, right? Important. Then one more very important thing which we need to know. Before that, north pole, south pole, how magnetic field lines travel from north to south. From north to south, magnetic field lines travel, right? Magnetic field lines, will it intersect anywhere in the middle? Intersection? No, it will not intersect anywhere. And one more important thing, by convention we have considered magnetic field lines will travel from north to south. Magnetic field lines will travel from north to south. By convention we have considered. Then, if the field lines are closer, if the distance gap between the field lines is less, then the magnet will be more stronger. The magnetic field strength will be more. Field lines are wider, then less magnetic power will be there. That's it. Earth makes a revolution around the sun, right? How much time does it take to revolve around the sun? 365 days. 365.25. 365 days for one revolution, right? This is a revolution. By the time of revolution, it is also rotating, right? This is called as rotation. Rotation in its axis while doing a revolution around the sun. How much time does Earth take for one rotation? 24 hours. One rotation makes a day, 24 hours, right? 24 hours it is taking. Earth is slightly inclined, right? Slightly inclined. How much degrees of inclination? 23 and half degree. See, while revolving around the sun, Earth is inclined to the axis by 23 and half degree. To this axis, 66 and half degree, total 90 degree. While revolving around the sun, inclined by 23 and half degrees to its axis of rotation, right? See, North Pole, South Pole. Let's say this is the axis, Earth. Magnetic North Pole and magnetic South Pole are not converging, are not at the same point as of geographical north and south poles. That means inside the Earth there is an imaginary magnet. Earth behaves as a magnet, right? Let's imagine Earth, inside the Earth there is a bar magnet. If we imagine like that, the imaginary bar magnet is 11 degrees away, or the inclination is 11 degrees. The inclination of imaginary bar magnet inside the Earth is 11 degrees to the axis of Earth's rotation. That means the geographical North Pole and magnetic North Pole are 11 degrees apart. But Earth is very huge, right? While traveling, 11-degree deflection will not cause that a huge problem. That's why magnetic compass will surely work to give us the proper direction. No problem. But know the angle. That's it. How much? 11 degrees. 11 degrees it is inclined. Okay. Then we have three different type of magnetic materials. Magnets are made. Have you heard about a magnetic hill in the Himalayan region? Magnetic hill. There is a region in Ladakh where if you park your car in the neutral, in that road, the car will move towards the hill, which is little slightly upward. The road is little up, then also it will move towards the hill because magnetism. Magnetite ore of iron. Magnetite, it is a naturally occurring magnet. Magnetite, naturally occurring magnet. Naturally occurring magnet. Magnetite. Then we can create artificial magnets with the help of iron, nickel, cobalt. By using iron, nickel, cobalt, we can create artificial magnets. Artificial magnets we can create. Diamagnetic materials, paramagnetic materials, then ferromagnetic materials. Ferromagnetic materials. Diamagnetic material means it will not attract towards the magnet. No attraction. Example, when you got a magnet, you generally trade with each and every object you come across, right? Will it attract to the wall? Will it attract to the wood table? Will it attract to us? You might have tried, right? Will it attract to wood? No. Plastic? No. Glass? No. Door? No. Metal? Yes. Golden earring? Will it attract? No. Try next time. It will not attract to gold. Okay. Diamagnetic material, bismuth, gold, etc. No attraction towards magnet. No attraction. It will not attract. Many other are there. We are taking NCERT examples. That's it. Then paramagnetic material, weak, feeble magnetic momentum. Physically, if we observe, there is no attraction. But microscopically, if we observe, the molecular level, if we observe, there is a weak magnetic momentum. There is no momentum, but we can feel the molecular force of attraction towards the magnet. That is paramagnetic material, aluminium, copper, manganese, etc. Then ferromagnetic material, ferrous means iron like, right? Ferromagnetic material, it will attract with the magnet, strong attraction towards the magnet. Artificial magnets are produced with ferromagnetic materials. Artificial magnets, iron, nickel, cobalt, iron, nickel, cobalt, Fe iron, Ni nickel, Co cobalt. Capital letter C, small letter O. Capital letter C, capital letter O means carbon monoxide, right? This is capital letter C, small letter O, cobalt, cobalt. Then we have ferromagnetic alloys, alnico, alnico, aluminium, nickel, cobalt. Famous alloy, which is used to create artificial magnets. Famous magnet. What we used to do when you were young, when we hear this noise? Okay. Acids and bases. Acids and bases. Example for any acid? Name acid. Any acid. Which acid is present in lemon? That's it. You can name many. If I ask, you will name, right? Which acid is present inside our stomach? Hydrochloric acid, the gastric juice, hydrochloric acid. Which acid is present in the battery? Sulfuric acid. Lead acid battery, sulfuric acid. Which acid is present in tamarind, grapes, unripe mango? Tartaric acid. Which acid is present in vinegar? Acetic acid. Acid. Okay. We'll discuss the basic concepts today. Tomorrow we'll discuss the examples, etc. in detail. Acid. The word comes from a Latin named word acere, that means sour. Sour means the taste. Sour. Kudi. Sour. There is one thing which you need to know. This is our tongue. Have we discussed this? Have we discussed? No, you are absent. Taste buds we have, right? To detect taste in our tongue. We can detect various tastes like salt, sweet, sour, spice, etc. Bitter, etc. Various type of taste we can detect. In our tongue, in each and every region, front, back, sides, middle, etc., we can detect all the taste. But in few region, particular taste buds are more in number. In Bangalore, each and every area is having a coaching institution, but more number of institutes are there in Vijayanagara, Chandralevate, etc. Right? In Bangalore, each and every area we get a automobile shop, but more number are there in JC Road. Like that, in tongue, each and every part we can detect taste, but in particular region, in the front, in the back, in the sides, we have special taste buds, more number of taste buds. In the front, we have taste buds to detect sweet taste. In the front, we have taste buds to detect sweet taste. In the back, we have taste buds to detect bitter taste. Bitter. Then at the sides, both the sides, we have salt and sour, salt and sour taste detecting regions. We don't have a particular region for spice, no particular region, everywhere. Sweet, bitter, salt, sour taste detecting taste buds. These taste buds are called as gustatory receptors. Gustatory receptors. Gustatory receptors. Taste buds called. Okay. During the time of fever or any disease, we might not be able to feel the taste, right? For example, during Corona, we couldn't feel both smell and taste. The condition during which we cannot feel the taste, loss of taste, that condition is called as agousia. In an examination, they asked agousia. Agousia means loss of taste. Agousia. Yesterday, I have seen a person wearing a T-shirt with a back print telling insomnia, where a person's T-shirt with a print naming insomnia. Insomnia. Okay. The term was asked in an examination. Insomnia. And in the print, there was a person wearing a monkey cap who was feeling very drowsy with red eyes, etc. He was like that. Insomnia means the condition in which you cannot sleep. Sleeplessness. Sleeplessness. You're trying hard to get the sleep, but you can't. That condition is called as insomnia. Insomnia. Sleeplessness. Then there is a condition called as somnambulism. Somnambulism. Similar. Somnambulism means sleepwalking. Sleepwalking. That is somnambulism. Insomnia, sleeplessness. Somnambulism, sleepwalking. Somnambulism. right? Similarly, smell detecting smell detecting buds are called as olfactory receptors. Olfactory receptors. These detect smell, olfactory receptors. During the time of corona, loss of smell, the condition, loss of smell, you cannot detect even smell. This is called as anosmia. Anosmia. Loss of taste, agusia. Loss of smell, anosmia. The term called as anosmia. Loss of smell. Acids are sour in taste, but we cannot taste all the acids, right? We can taste lemon, but we cannot taste sulfuric acid, hydrochloric acid, right? That's why we have indicators which change color and indicate whether it is acid or base. We'll see later. Acids are sour. Acids are sour. They will turn a litmus paper into red color. They will turn litmus paper into red color. Litmus paper, important indicator. Have you heard about litmus paper? Have you heard the name litmus paper? Have you seen an advertisement by Dove soap? Two white color soaps. They had two litmus paper. One litmus paper turned blue. One litmus paper turned red. They told that red color, it is harsh. It is not our soap. Blue color, mild. This is our soap. That is basic acid base test they have done. Each and every soap which we use will be generally basic. Generally basic. If your skin type is different and a doctor requires some acidic soap, then little bit less pH value soap they will give. Otherwise, generally the soaps will be basic, right? That simple test they have done for advertisement. Acid base test, litmus paper test. The paper will change the color with acid and base. With acid, red color. With base, blue color. Blue color. Bases are bitter in taste. Bases are bitter in taste. Bases bitter in taste will turn litmus paper to blue color. Blue color bases. If we touch the base, it feels soapy. When you touch the soap, the slippery feel will be there, right? It will feel soapy. Bases feels soapy. Feels soapy. It's bitter in taste, feels soapy. Base. What is the range of pH scale? pH scale 0 to 14. 7, huh? 7 neutral. pH scale. pH scale means potential of hydrogen. Potential of hydrogen. That means based on the hydrogen ion concentration. Based on hydrogen ion concentration. See, in all the acids, which element is commonly present means hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3, carbonic acid H2CO3, which is commonly present? H, hydrogen, right? In all the acids, hydrogen is present. Generally, acids will be having H plus ions. Bases will be having OH minus ions. Sodium hydroxide, potassium hydroxide, magnesium hydroxide, etc. Base. Based on the hydrogen ion concentration, this scale is made. Potential of hydrogen, potence of hydrogen, pH scale. 0 to 14, the scale is there. 7 middle value, this is neutral, nor base, neither acid. Okay, neutral value. 0 to 7 we have acids. 0 to 7 we have acids. 7 to 14 we have bases. 7 to 14 we have base. 0 to 7 acid, 7 to 14 base. Now tell me, if the pH value is nearly 0, whether it is strong acid or weak acid, pH value nearly 0, less than 7, nearly 7, then if the pH value is 7, it will be strong acid, less than 7 weak acid, more than 7 weak base, nearly 14 strong base, right? Right. For example, you are making lemon juice. You have added more number of lemon juice to a jar. Okay. It will be more sour, more sour, right? You are adding water or you are adding sugar. It will be neutral taste. Equal amount of sourness, equal amount of sweetness, right? Afterwards, you're still adding more sugar. It will become more sweeter, right? Likewise, strong acid, then weak acid, then it turns to base, then it turns to strong base. That's it. Nearly 0 pH value strong base, nearly 14 pH value strong, sorry, nearly 0 pH value strong acid, nearly 14 pH value strong base it will be. Okay. Snederia. Is it visible properly? Hmm? The letters are visible, right? You can read. The first one? Fine. See here. See. pH scale. Nearly 0, strong acid. Nearly 7, neutral. Below 7, weak acid. Above 7, weak base. Nearly 14, strong base. Right? Okay. See. In one examination, what they have done, they have given many acids. Option A, stomach acid. Option B, lemon. Option C, citric acid. Option D, coffee, etc. This type, they have given the options. And they have asked, order them in increasing order, arrange them in increasing order of pH value. Arrange them in decreasing order of pH value. We should be knowing the basic examples of acids and bases. Okay, let us see first one. Nearly 0 pH value, the acid present in the battery, the storage battery, not the remote cell, the storage battery, lead acid battery. The acid present in that battery is sulfuric acid, king of acids. It is also called as king of acids, sulfuric acid. H2SO4, nearly 0 pH value, strong acid. Okay. Then acid present in our stomach. Why acid is present in our stomach? To kill the harmful microorganisms which are entering with our food. We had food without washing our hands in a function. We had Golgappa, Pani Puri, etc. There will be so much bacteria, protozoa, etc. that will be killed with the help of acid present in our stomach. Which acid? Which acid? Hydrochloric acid. Acid present in our stomach, HCl, hydrochloric acid, HCl. Then lemon. See, if you study each and every subject thoroughly for UPSC CSA examination, your way of seeing things, your way of seeing the day-to-day life will change. Because, for example, recently my grandfather died due to age-related issues. He couldn't breathe properly. What happened? He couldn't breathe properly. Then he tried to drink some water. The water went to his lungs. It got filled with water. Right. Then one of my cousin, for relative, she's a doctor. She came and she was explaining to others, telling that actually there will be a lid like a structure which will open only when we respirate, which will be closed when we eat or swallow food. The lid is called as epiglottis, which we know as aspirants. We study each and every subject. If we speak with a doctor, we will be understanding what they are telling. If we speak with a person, historian, we will be understanding what he will be telling, right? The amount of knowledge which you gain is extreme, which you cannot gain in any of the other jobs. That's why it is a knowledge gaining process. Enjoy this, right? Try to learn more. That's it. Then stomach acid is HCl, hydrochloric acid. Then lemon, which acid? Citric acid, around 2 pH value. What happens if you apply lemon juice to your hand? Little burning sensation will be there. If you apply it to a black cloth, color will fade out. Lightly, color will fade out, right? Due to acidic action, acid. Then vinegar, gobi manchuri, transparent water bottle to give sour taste. What they will add to gobi manchurian? Soya sauce, chili sauce, tomato sauce, vinegar, right? Vinegar, transparent fluid. Next time observe the transparent fluid, that is vinegar, which is added generally to chats, etc. They use vinegar. Acetic acid is present. Acetic acid, vinegar. Tomato and spinach. Tomato is also slightly acidic. Tomato, spinach. Spinach means palak soup. In that, we have oxalic acid. Oxalic acid. Then coffee. Coffee is, I had coffee 3-4 times today. I haven't, I'm telling you. I had coffee 3-4 times today. I haven't had my breakfast and my stomach feels full. I don't want, I can't have lunch. Few people say, right? Because coffee is acidic. Tea, even tea is acidic. Soft drinks, Pepsi, Coke, Thumbs Up, etc. They are also acidic. What we feel, we had so much food, we should have some soft drinks so that digestion will be better, right? The gas will come out, the burp will come out, that's it. Burp you will get. But it is actually acidic. It will build up more gastric issue. It will not suffice it. Okay. The acid present in soft drinks is carbonic acid, carbonated soft drinks, carbonated water we say, right? Carbon dioxide is pressurized. Carbonic acid is present in soft drinks. Coffee is also, tea is also acidic. Milk, generally, a baby who is having only milk, right? He might get vomiting, acidity, etc. The child, cow's milk. Only in the morning he had a glass full of cow's milk. He is feeling little acidic or vomiting sensation. The main issue. Generally, at our home, what our mothers will do, they will add some water to the milk, right? Some amount of water to the milk. The main reason of adding milk to the water is not increasing the volume. The main reason is milk is slightly acidic, not heavily acidic, slightly acidic. Just below 7 pH value is there. So it should be added with some amount of water to maintain, to balance, right? Then water, not the normal water, the pure water. The pH value of pure water is 7. Pure water means which water? Pure water means drinking water is fresh water. Distilled water. Distilled water is pure water. Distilled water pH value is 7. Drinking water pH value is drinking water pH value is 6.5 to 7.5. The range 6.5 to 7.5. Drinking water pH value range. Virat Kohli drinks a special water. Which kind of water? Alkaline water, right? Alkaline water. Alkaline means basic. Alkaline, the term is nothing but base. The water should be more basic. Blood, slightly basic. The pH value of our blood is 7.35 to 7.45. Very sensitive pH range. The blood pH value cannot go below 7.35, cannot go about 7.45. The pH value range of our blood is 7.35 to 7.45. The range, the range. Then baking soda. Where do we use baking soda? To make the batter, etc. We use baking soda. Baking purpose, simply, right? Sodium hydrogen carbonate or sodium bicarbonate. Baking soda, bicarbonate. Sodium bicarbonate, baking soda. Then stomach tablet. Stomach tablet means antacid. If you have acidity, what will you have? Or Gelucil syrup, Digin tablet, right? Various different brands are there. The tablet, the syrup which you are having will be having a chemical called magnesium hydroxide. Next time, if you are having a Gelucil syrup, Digin syrup, the thick whitish pinkish syrup, when you have gastric, generally if you have, we don't have that issue. Generally aged persons, they will be having stomach tablet, magnesium hydroxide, milk of magnesia, then ammonia solution, bleach, that is also base, drain cleaner, base. Those are not acids. We do use acids for cleaning purpose, but general cleaners are bases itself. Then soap. See, we have washing soap and bathing soap. Washing soap means utensils washing, dishwashing, or clothes washing, right? Washing soap is produced with the help of sodium hydroxide. We'll discuss that later. Sodium hydroxide is used to produce washing soap. Sodium hydroxide. Potassium hydroxide is used to produce bathing soap. Potassium hydroxide. Generally, at your home, you are using a soap to wash clothes. These days, washing machine, powder, liquid we are using. If in case you are having soap, on the packet of the soap, it will be written Rin detergent bar. Ghadi, Surf Excel, detergent, it will be written, right? We are not using soap for cleaning purpose. We are using detergent. The main reason is soap will not give lather, foam, froth with hard water. Soap will not give lather, nor a barilla. That's why we use detergent for cleaning purpose instead of soap. But to our skin, there is no option. We cannot use detergent. That's why I use soap itself. Either it gives more or less lather, right? The reason of lather means cleaning action. If more lather comes, froth comes, cleaning action will be better. That's why. Generally, for cleaning purpose, we are using detergent, right? Tomorrow's class will continue this topic. Probably from next week, probably from next Monday. Tomorrow we'll try to cover this. We'll start with if in case if it not gets covered by tomorrow, we'll cover it on Monday. Later from Tuesday at least, we'll start with the previous year question paper. We'll discuss. First, we'll discuss the examination pattern once clearly. Then we'll discuss the cutoff marks. Then we'll discuss how many questions will arise from science and technology. Then that too, where more importance, more weightage, which we should give, which topic we'll discuss. Later, we'll see some questions. I will only tell the answers so that you will get to know the difficulty level of the questions which are arising in these years. Later, we'll start with the topics, the proper technology topics, space, defense, biotechnology, etc. Right? I will give PDF notes for those topics. No need to worry. Thank you.